This video is to review solving system of equations. So there's two methods of solving for a system of equations that we're going to review: substitution and linear combination, also known as elimination. So first we're going to go through substitution. In substitution, remember that you need to have one of the variables by itself. So in one of your two equations, you need to have an x equals or a y equals. So in the first equation, we have y equals 2x plus 3. We're going to take what y equals and we're going to substitute it for y in the second equation. So everything else in the second equation stays the same, but we're replacing the y with 2x plus 3. That's where the substitution comes in. So when I rewrite the equation, I have 2x plus 4 parentheses 2x plus 3 equals 32. Now that I notice I only have one variable in my equation, so I'm going to solve for x. So to solve for x, we distribute to get rid of the parentheses. 2x plus 8x plus 12 equals 32. Notice that we have two x terms, so those can combine together. So 2 plus 8 is 10x plus 12 equals 32. The next step would be to subtract 12 from both sides. So 10x is equal to 20. And then we're going to divide by 10 on both sides, so x is equal to 2. Once we know our x value, we still need to know what y is. So we're going to take our x value and substitute back into one of the equations. It doesn't matter which equation you use once you know the value of one variable. So since we know x, it doesn't matter. I'm going to use the first equation this time, though. So y equals 2 times 2 plus 3. So 2 times 2 is 4. Plus 3, y is equal to 7. Remember, once you have both variables, we always write it as a coordinate. Now, number 2 is still a substitution problem. That method can be utilized, but we have to do one step first. We need to get the x or the y equal and by itself on one side of the equal sign. So the first equation is hard because this is a 6x non-x. The second equation, though, is just x minus 2y. So we need to move the 2y away from the x. So we're going to add 2x to both sides, or 2y to both sides. So x equals -1 plus 2y. Now that I have x by itself, I can take what x is equal to and substitute into the other equation. So I haven't worked with the first equation yet, so I'm going to substitute in for x there. So 6 parentheses -1 plus 2y plus 3y equals 9. Now my equation only has one variable, so I'm going to continue solving. So I'm going to distribute 6 into the parentheses. -6 plus 12y plus 3y equals 9. Combine my y's. -6 plus 15y equals 9. 6 is negative, so we're going to add it to both sides, so 15y equals 15. And then divide by 15, so y is 1. Once we know that y is 1, remember we have to go back and get the other variable. So we're going to take the value of 1 and substitute into either equation. This time I'm going to substitute into the second. X minus 2 times 1 equals -1. 2 times 1, -2 times 1 is -2 equals -1. Add 2 to both sides, so x is equal to 1. So our ordered pair would be 1, 1. Now, for the three remaining problems, we're going to work on using linear combination or elimination. Linear combination or elimination requires that you have the same number in front of a variable with opposite signs. So in number 3, we have a 5x and a -5x. So those cancel out because they're the same number in opposite signs. They would add to 0. That's how we get a variable to cancel out. So everything else is going to be added straight down. We get 17x equals 34. And now all I have to do to solve for x is divide by 17 on both sides, and we get x equals 2. Just like above, once we know one of our variables, we need to go back and get the other one. So I'm going to use the first equation this time, though it doesn't matter. So 2 times 2 plus 5y equals 24. 2 times 2 is 4, plus 5y equals 24. subtract 4 on both sides, so 5y equals 20, and divide both sides by 5, so y is 4. So our ordered pair would be 2, 4. Now, 4 is a little trickier because we don't have any variables that cancel out right now. So instead, we're going to look and see, how can I multiply one of them to cancel out with the other? So do I know something that multiplies by 3 to get to 5 or 2 to get to 4? I know something that multiplies 2 to get to 4. Remember, I need opposite signs. So if this equation has a positive 4, the other equation needs a negative 4. So I'm going to multiply by negative 2. Make sure you multiply all three terms by negative 2. So negative 8x minus 6y equals negative 8. We didn't do anything to the second equation, so we're just going to rewrite it. Sorry, negative 4x, not 8, negative 4x. So this time, my x's cancel out because negative 4 plus 4 is 0. So when I add straight down, I get negative 11y equals negative 44. Divide by negative 11 on both sides, so y is 4. Once we know that y is 4, we're going to take that value and substitute back in. So again, I just picked the first equation. 5x plus 3 times 4 equals 4. So 2x plus 12 equals 4. Subtract 12 from both sides, 2x equals negative 8. Divide by 2, so x is negative 4. So this ordered pair would be negative 4, 4. Remember, when you're writing ordered pairs, it's always your x comma y coordinate. It's not which one you solve for first, it's always x comma y. Let's look at one last problem. So 2x plus 3y equals negative 6. 5x minus 2y equals negative 34. Now, in this case, I can't easily multiply my smaller number 2 to get a 5, or my smaller number 2 to get a 3. So I'm going to have to multiply both equations. When you get to multiply both equations, you get to essentially pick which variable you want to cancel out, and it doesn't matter. One's not better than the other. In this case, because I have opposite signs with my y's, I'm going to choose y's. So 2 and 3, I can't get those one to multiply to the other, but I know that they have a common multiple. They both multiply to 6. So I need to multiply both equations to get a 6 and a negative 6. So in my first equation, I'm going to multiply by 2. My second equation, I'm going to multiply by 3. I don't need to worry about multiplying with a negative since I already have the positive and negative signs in there. So distribute to everything. 4x plus 6y equals negative 12. And 15x minus 6y equals negative 102. So this time, when I go to add straight down, my y's cancel out, and I'm left with 19x equals negative 114. And then I can divide by 19 on both sides, and I get x is negative 6. Once I know x, I need to go back and get y. So I'm going to substitute into the second equation this time. 5 times negative 6 minus 2y equals negative 34. 5 times negative 6 is negative 30, minus 2y equals negative 34. Add 30 to both sides, so negative 2y equals negative 4. And then divide by negative 2 on both sides, so y is positive 2. So I would rewrite this as negative 6, comma 2.